Welcome to Global Insights. Today, we're diving into one of the most fascinating and mysterious phenomena in the universe, black holes. These cosmic giants are so powerful that not even light can escape their grasp. But what exactly are black holes? How do they form and what makes them so mysterious? Stick around as we unravel the enigma of the most mysterious objects in the universe. First things first, what is a black hole? Simply put, a black hole is a region in space where gravity is so strong that nothing, not even light, can escape its pull. This immense gravitational force is the result of a massive amount of matter being squeezed into a tiny space. At the center of a black hole lies a point of infinite density called a singularity, where all the matter has collapsed into a single point. Surrounding the singularity is the event horizon, the point of no return. Once something crosses this boundary, it's impossible to escape. The event horizon is what gives black holes their name, as no light can escape from this region, making the black hole appear completely black against the backdrop of space. Black holes are born from the death of massive stars. When a star much larger than our sun runs out of fuel, it can no longer support itself against the force of gravity. The star collapses under its own weight, triggering a supernova explosion. If the core that remains is dense enough, it will collapse further into a black hole. The gravity becomes so intense that not even the star's own light can escape, leaving behind a black hole. But black holes aren't limited to the remnants of dying stars. There are also supermassive black holes, millions to billions of times more massive than our sun. These behemoths reside at the centers of galaxies, including our own Milky Way. How they form is still a mystery, but they play a crucial role in the evolution of galaxies. Not all black holes are created equal. There are three main types of black holes: stellar black holes. These are the most common type, formed from the collapse of massive stars. They typically have a mass between 3 to 10 times that of our sun. Supermassive black holes. These giants are found at the center of most galaxies and have masses ranging from millions to billions of times that of the sun. Our galaxy's supermassive black hole, Sagittarius A*, has a mass equivalent to about 4 million suns. Intermediate black holes. These are a middle ground between stellar and supermassive black holes, with masses ranging from hundreds to thousands of times that of the sun. While evidence for intermediate black holes is still limited, their existence could help explain how supermassive black holes form. There's even a theoretical fourth type called primordial black holes, which could have formed shortly after the Big Bang. If they exist, they could be as small as an atom but with the mass of a mountain. Black holes don't just trap light, they also warp space and time around them. The closer you get to a black hole, the stronger the gravitational pull becomes. If you were to fall into a black hole, you'd experience something called spaghettification. As you approach the event horizon, the difference in gravitational pull between your head and feet would stretch you out like spaghetti. Not a pleasant way to go. But that's not all. Time also slows down near a black hole. According to Einstein's theory of general relativity, the stronger the gravity, the slower time moves. Near a black hole, time could slow to a crawl compared to an observer far away. In theory, if you could survive close to the event horizon, you might see the universe's future unfold in fast forward. With all this talk of gravity and destruction, you might wonder, could black holes destroy the universe? Fortunately, the answer is no. While black holes can consume anything that gets too close, they don't actively seek out matter to devour. In fact, if our sun were replaced by a black hole of the same mass, the Earth would continue orbiting it as usual, just in total darkness. However, black holes can grow by merging with other black holes or by consuming nearby matter, such as gas and stars. These cosmic feasts produce massive amounts of energy, often seen as powerful jets of radiation. But rest assured, black holes are more of a localized threat than a universe-wide one. Black holes aren't just mysterious, they're also a frontier of scientific research. In 2019, the Event Horizon Telescope captured the first ever image of a black hole, located in the galaxy M87. This groundbreaking achievement confirmed many predictions made by Einstein's theory of general relativity and opened up new avenues for understanding these enigmatic objects. Black holes could also hold the key to some of the universe's biggest mysteries. Scientists are exploring the idea that black holes might be connected to wormholes, tunnels through space-time that could, in theory, allow for faster-than-light travel. Others speculate that the singularity at a black hole's center could offer insights into quantum gravity, potentially uniting the theories of quantum mechanics and general relativity. Black holes are among the most fascinating and mysterious objects in the universe. From their mind-bending gravity to their role in shaping galaxies, these cosmic giants challenge our understanding of physics and push the boundaries of science. As we continue to explore the cosmos, who knows what other mysteries black holes might reveal? If you enjoyed this journey into the unknown, be sure to like, share, and subscribe to Global Insights for more deep dives into the mysteries of the universe. Thanks for watching, and until next time, keep looking up at the stars. Outro music swells as the end screen appears with calls to action. Subscribe, watch next video, etc.